Here's your review for exponentials. As always, it's best if you try first. Do your best. If you're stuck, watch the video so it can help you get through it, but really try to be independent. So I want to graph y equals 4 to the x. So I need 2 points. So 1 point is on every exponential, 0, 1. And 4 is bigger than 1. So the other point would be positive 1 and 4. And the asymptote at y equals 0. That's it. So I'm going to go find 0, 1. I'm going to find 1, 4. And the asymptote at 0. And then I'm going to draw the exponential curve using those points. Next, underneath, I'm going to write down the domain. That's always all real numbers. I'm going to write down the range. That's the bottom to the top, so that's 0 to infinity. And then the end behavior. See if I have room here. So as x approaches infinity, the right end goes up. As x approaches negative infinity, the left end goes to the asymptote, which is 0. All right, why don't you try number 2? Press pause. For number 2, the 2 points are going to be 0, 1, but now it's going to be negative 1 and the reciprocal with y equals 0. So we're going to graph this and the asymptote. I'm going to curve it. So there's my graph. I'm going to do the domain here. That's all real numbers. I'm going to do the range right here. So the bottom to the top of the graph. And then the end behavior. So as x approaches infinity, now notice the right end goes to 0. As x approaches negative infinity, the left end goes up, which is infinity. All right, try number 3, and then watch the video for support. So the first point, as always, is going to be 0, 1. And the second point is going to be 1, 2, because that's the base. And then we're going to graph it. So 0, 1, 1, 2, and the asymptote at 0. So we're going to curve this. So we have one curve that's rising left to right. The domain is always all real numbers. The range, is that range? That's kind of spelled like rain. The bottom to the top of the curve. And then the end behavior. So as x approaches infinity, the right end goes up. As x approaches negative infinity, the left end goes to 0. Number 4, press pause. Try it first. So again, 0, 1 is going to be negative 1 in the reciprocal and y equals 0. So we'll start at 0, 1, then negative 1, 2, and then the asymptote at 0. Right? The more we practice these. And then the curve using that. The domain is always all real numbers. There's no restrictions. The range, the bottom of the graph to the top, goes 0 to infinity. And the end behavior. So as x approaches infinity, the right end goes to 0. As x goes to negative infinity, the left end, goes up. That's positive infinity. All right, turn the page. Now what's different about the graphs here on this side is that there's a number multiplying. So we start with the basic exponential. So just 1/2 to the x. What are again 2 points and the asymptote? And then if I put these on my graph, so 0, 1 and negative 1, 2, right, there's my basic exponential. I then multiply only the y values times 4. So the y is the second number. So 1 times 4, and then 2 times 4. And I move the point to those numbers. So instead of 1, it moves to 4. Instead of 2, it moves to 8. It gets stretched. And the asymptote stays exactly the same. So when you multiply times 0, it stays. This is the curve that I'm looking for. In fact, I might not even write down the basic exponential, I'll just write it down, multiply, and just have one curve on the graph. The domain here is all real numbers. The range from the bottom to the top goes 0 to infinity. And then the end behavior. So the right end goes to 0 and the left end goes to infinity. So know the right end from the left end. All right, number 6, you try. Press pause, see if we can graph it. So again, I'm going to start with the basic exponential. And then the 2 points are 0, 1, and 1, 2. And then multiply to change them. So I'm only going to multiply the y value. So 1 times negative 5 and 2 times negative 5. So this is what I'm going to use. So I use this to get to what I want. That's what I want. So I'm going to find 0, negative 5. I'm going to find 1 and negative 10. And then the asymptote always stays at 0 when you multiply. And then I use those points to curve the exponential. There it is. The domain is all real numbers. The range. Now be careful here. Because there's been a reflection, this is now, instead of pointing up, the negative now makes the exponential point down. The bottom of the graph is negative infinity, and it goes up to the asymptote, which is 0. So be careful when it's been reflected. Then the end behavior. So the right end goes down, and the left end goes to the asymptote, which is 0. So know your end behavior, domain, and range. Know how to change the points and use them. All right, number 7. Again, if we want to do well on the exam, we have to be independent. So I want you to try it first, then press play, and let me help you. So start with the basic exponential. That's just 2 to the x. What are 2 points on there? And then we're going to change these points. So how are we going to change these points is we're going to multiply times 4. So only the y value. So that's 4. And that's 2 times 4, which is 8. So those are the points I'm going to use. 0, 4, and 1, 8. The asymptote does not change when you multiply. And so it stays at 0, and then I draw my graph from there using those 2 points. The end behavior, the right end goes up. The end behavior, the left end goes to 0. All right, number 8. Again, try it first, then press pause. So the basic exponential is just 1/2 to the x. So again, the point 0, 1 and negative 1 and the reciprocal, which is 2. So we're going to multiply these and then put them on. So what number are we multiplying times? So when we multiply 1 times negative 3, we find negative 3. When I go 2 times negative 3, that's negative 6. So I'm going to go 1 to the left and 6 down. The asymptote stays at 0, and then I curve using those points. The end behavior here. So as x approaches infinity, the right end goes to the asymptote. As x approaches negative infinity, the left end goes down. So know which way the ends are going. All right, turn the page. Number 9. So, again, I want the basic exponential. And I want 2 points. So 0, 1, and negative 1, 3. I'm going to put those on my graph. I'm just going to make them x's. So 0, 1, I'll make that an x. And negative 1, 3, I'm going to make that an x. So those are my basic points. But now I need to know what direction I'm going. So a negative in the exponent means to the right, and a negative after means down. So the direction we're going is to the right 2 and down 1. So each x. So here, count. So to the right 2 and down 1. Here, to the right 2 and down 1. Now, the asymptote is also going to move. So from 0, it's going to go down 1. So now it's at, and write that number down, which is negative 1. We need that number. And now this is what we're going to use to draw our graph. And then the domain, I'm going to put that over here. The domain, again, is all real numbers. The range, you got to be careful here where the asymptote is. So from the bottom to the top. Now the bottom is at -1. So from -1 to infinity, and then the end behavior. So the right end goes to -1, and the left end goes up. And you have it all together. All right, number 10, again, press pause and do your best first. The basic exponential is just 2 to the x. That's 0, 1, and 1, 2. So I'm going to put those on my graph. So 0, 1, and 1, 2. And then I'm going to move it. So this means 1 to the left, and this means 1 up. So each x, I'm going to go 1 to the left and 1 up. 1 to the left and 1 up. So there they are. Now this will also changes my asymptote. So now my asymptote is also 1 up. So that means it's at 1. So from 0 you go 1 up, and there it is. And then you draw your exponential using that. The end behavior, as x approaches infinity, the right end goes up. As x approaches negative infinity, the left end goes to the asymptote, which is at +1. So keep practicing the analysis in the graph. All right, number 11. What am I going to say again, right? You got to try it first. So press pause and try it first. The basic exponential, so it's 0, 1, and 1, 4. So I put that on my graph, 0, 1, and 1, 4. And it's going to make them x's. And then read it. So this means to the left 2, and this means down 2. So left 2, down 2. So each one here. So I'm going to go left 2 and down 2. Here, I'm going to go left 2 and down 2. And then the asymptote, I'm going to go down 2. So from 0, it goes down 2. So it's at -2. And then I'm going to draw the curve from there. The end behavior. As x, did I forget the domain range in the other one? I think I did. Here, let me go back here. I forgot the domain is always all real numbers. But the range, we got to be careful of the range. So for the range, the asymptote is at 1. So it goes from 1 to infinity. All right. Sorry about that. All right, I won't make that same mistake here. I'll do the end behavior first. So the right end goes up and the left end goes to the asymptote, which is at -2. And then the domain is always all real numbers, and the range, so look carefully off the graph, so the bottom to the top, so that's -2 up. All right, this is our last graph, number 12, I think, right? Yeah. So the basic exponential, and then 2 points and an asymptote. So the 2 points here are 0, 1, and 1, 3. So 0, 1, and 1, 3. And then know what direction we're going. This means left 2, and this means down 2. Same thing as the other one, right? Yeah, left 2, down 2. So each x. So here, go left 2 and down 2. There it is. Here, left 2 and down 2. Here it is. And the asymptote goes down 2. So now it's at -2. There's the graph. The end behavior, so the right end goes up, the end behavior, the left end goes to the asymptote, which is at -2, and the domain and range. So the domain is all real numbers, and the range goes from the bottom to the top. So it's -2 to infinity. Great job graphing. All right, next page. On the next page, we're solving equations. To solve an exponential equations, the bases must match, and you make the exponents equal to each other. So number 13, both the bases match. So just take one exponent equal to the other exponent and then you're going to solve it. So how we solve a basic equation is to do the inverse of what I see. So to undo adding 2, we subtract 2 to both sides. So 2 take away 2 is 0. To undo the inverse of multiplying, we divide. So we divide by 2. And 0 divided by 2, and there's my answer. In number 14, in fact, I'm going to do this so I know I have enough room for everything. All right, number 14, the bases are the same. So take the left exponent equal to the right exponent, and then we're going to solve it. So the inverse of negative k is to add k to both sides. So these eliminate. That's 3. This is 1k, so 3 plus 1 is 4. And then the inverse of multiplying is to divide. You don't have to reduce it down. You could say it's 1/2, but 2 over 4 is a good answer too. But it is a fraction. Number 15. The bases are the same, so we take the exponents and make them equal to each other. So we're going to, what's a good move here? I'm probably going to subtract 3k to save some steps, though I usually like making the variable positive, and then I'm going to divide by -6. I need to know that a negative divided by a negative gives me a positive answer of 1 over 6. All right, number 16. All right, these bases are not the same. So I need to have the math ability to change the number 81 so it has the same base. So 9 to what exponent is equal to 81? That's what I need to know. So that's the math I need. Now the bases are the same. Make the exponents equal to each other and solve it. So we're going to subtract 1 and then divide by 3. So I subtracted 1 and then I divided by 3. The 3's cross out and gives me 1/3. All right, number 17. Again, the bases are not the same. So 4 to what exponent is equal to 16? So that's 4 to the exponent 2. The exponent that was already there, they're going to multiply together. So on this side, I have 2n plus 2. And then on the other side, to answer this, we're going to distribute. We're going to multiply. So 2 times 2 is 4. 2 times 2 is 4. And then this is what we're going to solve. So I'm going to subtract 2n. So 4 take away 2 is 2. I'm going to add 4 to both sides. So 2 plus 4 is 6. And then the last step is to divide by 2. So 6 divided by 2 gives me the answer, which is 3. 18, again, I need the bases to be the same. So instead of 4, I take the smaller base. I use it as a common base. 2 to what exponent is 4? So 2 to the exponent 2 is 4. There's already 3n, so they multiply together, and then you divide and have your answer. This number is a little bit bigger, but we can do it. 64 is 4 to the exponent 3. That means 4 times 4 times 4. Take the exponents, make them equal to each other, and then solve it. So we're going to add 1. I'm going to divide by 3, and then I have my answer. So the answer is 4 over 3. Number 20, a little bit of a thinker. Not too bad. So it's not going to be a base of 1. Instead, we're going to change it to a base of 5 and know that 5 to the exponent 0 is equal to 1. So the exponent 0 always gives me the answer 1. Now the bases are the same. Make the exponents equal to each other, and 0 divided by any number, the answer is 0. All right, 2 more. I need the bases to be the same, so instead of 16, it's 4 squared. Then take the exponents and make them equal to each other. There's not even anything to solve after that. That tells you what n equals. And then number 22, the bases are the same. So just take the exponents equal to each other and then solve it. And you have the answer. So when you subtract 2a, 3 take away 2 is 1a, and that's equal to 2, and there's your answer. All right, great work practicing solving exponentials. All right, our last one, our last page, has to do with stories. about exponential growth and decay. So let's look at them. Let's see if we can annotate and remember the equations we're going to use. All right, here we go. It's not getting clear. So $5,000 was invested in an account with an annual interest rate of 7%. Let's see if we can get it to focus. I don't know. It may or may not. So $5,000 was invested. And the formula is for growth. So A is the original amount, 1 plus R. Now the challenge here is I have to have the skill to write that as a decimal. So I'm going to move the decimal back to, and 7% means 0.07. That's a skill. And then how much after 8 years? That's the exponent. And then we actually need a calculator. So I want you to go to Desmos.com. It's right here. So I'm going to use Desmos, and I'm going to type it in. Exactly what's on your page. And then there's the answer. So it's $8,590.93. So we're going to set it up and then use that, and there we have our answer. And then we're going to write a simple sentence. All right, next one. A herd of buffalo increases at a rate of 2% per year. If the herd's population is 50, what will the population be in 10 years? All right, so same formula that we're going to use here. So we start with the initial population, 1 plus, and we need to change this to a decimal again. So move the decimal, and it's 0.02, and then the exponent is 10. And now we need a calculator. So this is what we're going to put into Desmos. So again, we're going to put in 50, 1 plus 0.02, and then to the exponent 10. And we're going to round it. So we can't have 0.9 buffalo, so it's going to be 61. And there's our answer. So in 10 years, the population of buffalo will be 61. All right, number 25. A $25,000 car depreciates. That means it goes down in value 3% per year. How much will it be worth in 4 years? So the formula, so it's 25,000. Now, because it's going down in value, we don't add, we subtract. And then the percent as a decimal, and then the years, which is 4, and then that will give me how much the car is worth. So again, at this step, we go to a calculator, Desmos.com, type in 25,000. That's too many zeros. There it is. And then 1 minus 0.03 to the exponent 4, and the car is going to be worth $22,132.32. And then we write a basic sentence for that. So in 4 years, the car will be worth $22,132.32. All right, number 26. A town's population is decreasing at 3%. If the current population is 10,000, what will the population be in 12 years? So it's 10,000. And because it's decreasing, we're subtracting. 3% is 0.03. And then 12 years is the exponent. And now we use Desmos to calculate it. So again, it's 10,000. Oops, there it is. And then it's 1 minus 0.03 to the exponent 12. And again, it's people, so it's a whole number. So we're going to go 6,938. So in 12 years, the population will be 6,938. All right, number 27. You invest $100 in an account with an interest rate of 8%. Now, this is compounded monthly. So we're going to talk about that. How many months are there in a year? We're going to need that number. And then how much will be there after 20? So let me write down the formula that we're going to use, and then we'll put in the numbers that we need from the formula. So this is the formula. You don't have, it's going to be in your black book or whatever right there, so you get to use it. And so P is the beginning amount. Sometimes it's called the principal. The rate as a decimal is 0.08 divided by N. That's how many times a year it's being compounded. And then N times T, we're going to multiply those numbers together. This is what we're putting in the calculator. So come back here to Desmos, and we're going to type that in. So it's 100, 1 plus 0.08 divided by 12. Now be careful with Desmos. When you go with the exponent, you need parentheses now. So put in parentheses and then 12 times 20, and then it will calculate it for you. So it's $492.68. So what do we got? In 20 years, $492.68 will be in your account. All right, last page. 3 more questions. You invest $500 in an account with an interest rate of 9%, compounded weekly. So how many weeks are there in a year? We need that number. Just so you know, it's 52. How much will be in your account in 10 years? So the formula is 500, 1 plus, we change 9% to 0.09 and divide by 52. And then in the exponent is 52 times the 10 years, and that's the formula we're going to use. Now we go to Desmos and type it in. So it's 500, 1 plus 0.09 divided by 52. Make sure you use parentheses, then 52 times 10, and you get $1,228. $1,228.85. And then write a basic sentence down. So in 10 years, $1,228.85 will be in your account. I'll show it to you. All right, 2 left. Always press pause. Always try first. You invest $3,000 in an interest rate 7% compounded quarterly. Quarterly means 4 times a year. How much will be in your account after 8 years? Try the formula first, then press play. So it's 3,000, 1 plus 0.07 divided by 4, and then it's 4 times 8. Were you able to do it? All right, let's do Desmos now. So again, that's 3,000, 1 plus 0.07 divided by 4. To the exponent, use parentheses, and it's 4 times 8, or you could just put in 32. And you get $5,226.64. And then we'll write a basic sentence. So in 8 years, there will be $5,226.64 in your account. All right, last question. All right, here we go. Again, try first. Why not, right? Then press play. You invested $900. The interest rate is 12%, compounded semi-annually. That means twice a year. How much will be in your account after 13 years? Again, press pause and try to set it up first on your own. So it's 900, 1 plus 0.12 divided by 2, and then in the exponent is 2 times 13. Did you get it right? Then use Desmos, or if you have a calculator, and we're going to type it in. So it's 900 That's 1 plus 0.12 divided by 2. And then it's parentheses, right? 2 times 13, or 26. And there you go. So it's 4,094 and 44 cents. All right, let's write a basic sentence, and then the review is done. If you can do this, you're going to do great on the exam. So after 13 years, $4,094.44 will be in your account. And that's it. You did it. Great job. So good luck on your exam. I hope this helped working with me. Mr. G Math, over and out. Till next time.